Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at Databricks. I'm joined by my co-host,
Ben Wilson. I do quarterly planning at Databricks for my team,
just your team, no other teams.
just my team. That's it.
Cool.
And ask other people for assistance and then promise assistance to other teams. But yeah, that's what I'm doing this week, I should say.
Congratulations. We appreciate everything that you do for us. So today we're speaking with Sandy. After graduating from Brown, where he studied computer science, Sandy started his career at Cloudera as a data scientist. He then took a variety of roles, including product manager, ML engineer, manager, and then finally he settled at Dagster Labs as a lead engineer. So Sandy, you lead the open source side of Dagster and have a long history of open source contributions. Why open source?
Man, tough question. I think I'd naturally gravitate towards open source, but I think I've also rarely tried to put down in words what the appeal is. With open source, you feel like you're kind of contributing to some sort of broadly useful edifice that can be reused as part of the world. Software and products go away, but a lot of open source technology from a very long time ago is still out there in the world. There are a lot of people outside of enterprises that still need to process data, that still need to work with technology, and open source kind of allows them to leverage technology without needing to pay or go through some sort of like difficult on-ramp or process with a business. So, I think, open source is more easily used in science. There's just all of these benefits that come out of a product being open source that you don't get with fully proprietary software. It's also good for business in other ways, but maybe that's less of the deep philosophical appeal for me.
Got it. So you feel that it's just more meaningful work because anybody can use it, and if it's a good product, it helps the world generally.
That's a much more succinct way of expressing it. Yes.
Cool. All right. So you mentioned also that it has this interesting permanence, and it doesn't really go away unless someone deletes a repo. And if it's getting some usage, it probably won't get deleted. So speaking of that, I was going through your GitHub and found an old repo. I think the last commit was like 7 or 8 years ago, and it was called Spark Time Series. So I used to do a lot of time series forecasting. Ben built a bunch of time series forecasting models. Why use Spark for time series specifically? And also, I'm curious, why didn't that model get any adoption?
Yeah, so I think that's an interesting counterpoint. Spark Time Series is a project that has lived on in perpetuity to my dismay, perhaps. I often get emails asking for support with Spark Time Series, and it's like I wrote on the GitHub that I would not be supporting this anymore. Wish I had the time to, but just wasn't able to. So sometimes open source software can outlive its utility. Let's see. So I developed Spark Time Series when I was working at Cloudera, what feels like ages ago. This was kind of in the early days of Spark. And I had been working in Cloudera's data science organization with a lot of customers in the like financial services, sort of dealing with financial data, which often takes time series formats. And I wanted to help them understand that the tools that we were building could help them work with the kind of data that they were working with. At the time, Spark was very focused on big data processing. Sort of the idea was like, okay, if you're doing small data, maybe you're fine with pandas. But if you're working with large data, maybe you should work with Spark. But that kind of bifurcation, I think, is a little bit difficult. Like, okay, I have to switch to an entirely different set of software and APIs once my data reaches a certain threshold. I think that's not a very good development experience. So even though time series often is a bit more of a small data problem than a big data problem, people often work with like thousands of or millions of time series in parallel. So even if each individual time series is very short, You can have tons and tons of them. And second of all, if you can use the same tool for small data that you use for big data, then you have to spend less time refactoring and rewriting your code.
I've got a question for you about the difference between your experience and because I have my own experience, which is very similar, doing a couple of open source projects that rely on another framework and then also working on a framework itself. How do you view the difference between writing code that is highly dependent on a very popular framework that you have zero control over versus you writing and maintaining something that you're obviously using other open source packages, like all of us do, oh, I need to work with data frames. I'm using pandas or I'm using NumPy. So we all have dependencies, but those are very tightly controlled and not a lot of breaking API changes. But when you're dealing with a hot open source framework, what's the difference? How is your experience different between that?
Yeah, definitely adds some challenges. So at the time that I was working on Spark time series, I was actually a core Spark committer as well, which meant I had some ability to change the underlying project, but also it had so much momentum that my, whatever I could do individually was outweighed by everything else that was going on in the project. So I think your question still applies. It really depends on how stable and the project is. I think Spark has changed quite a bit since the time that I wrote the Spark time series library. RDDs were the central abstraction back then. That's basically been entirely replaced with data frames and data sets. And so that means you end up having to kind of tread water just to stay afloat of what's going on. This was even worse in the world of Hadoop and MapReduce, which I had worked on before Spark, where they had two different versions of the core MapReduce APIs that just lived together. And anyone writing on top of MapReduce just had to, write two versions of their own API in order to work with those two different MapReduce APIs. So I at least appreciate that Spark kind of made a more concerted effort to move people into the future. Although RDDs, I believe, are still around. Some people still use them. So yeah, it makes it tough, not just for yourself as the developer, but for the users building on top of your library that kind of have to deal with everything that bubbles up from the core framework.
Yeah, we've felt that pain. We maintain a bunch of stuff on the team, including Spark ML. That's our responsibility, which I'm sure you're familiar with, is largely RDD based for a lot of those algorithms.
Yeah, I think I actually wrote the one hot encoder for that a long time ago.
Yeah, hopefully we actually just did a PR for a string indexer yesterday.
Nice.
To update that to support a new functionality. But when you're talking about one of those core algorithms, when you start looking at how does linear regression work? And you look at the code and you're like, oh, this is all RDD. And in a future version of Spark that's going to be released sometime later this year, RDDs are banned from being used in Spark. You can't use them. The APIs are sort of, they're deemed unsafe for interface.
Sufficiently buried to
But from the actual new Python focused API, you can't call algorithms in a safe way that utilize RDDs. So it has to be done in the secure data frame API. And you look at how that's done, you're like, I don't know how long it's going to take to actually rewrite this core algorithm, because I now have to rewrite an optimizer I understand it in RDD land, but now abstracting that to data frame operations, it's like, can we do this performantly? And we, do a prototype real quick and wow, this is 10,000 times slower. We need to think about this a little bit. And those sorts of changes, when you're like, hey, my whole library that integrates with this product is written in something that they're taking away from the community. At what point do you start to say, I mean, you already made the comment on the repo saying I don't have time to support this. I like it and I think it's cool, but I don't have the capacity. When do you actually tell users hey, as of this date, this is an archived project?
Yeah, I mean, first of all, that sounds like a challenging, but perhaps fun job that you have ahead of you. Second of all, I'm kind of surprised it's taken this long, given how long ago Spark moved away from RDDs. Third of all, yeah, I mean, it really depends on what's driving your commitment behind the original project, right? In my case, it was this kind of proof of concept for Spark and time series data. And I think it outlived its utility. But a lot of people depend on Spark ML, right?
There's a few, 1 or 2 companies out there.
That's right. So it sounds like archiving it is not always in the cards.
Oh yeah, we're definitely not archiving that.
But yeah, I do think that in many cases a change like an underlying framework is big enough to kind of kill projects that live on top of it, or that they can be the final straw that like leads the contributor to stop working on it, and the project kind of languishes into oblivion.
I have a question for both of you. So when you're building a new project, you have to choose your stack. Let's just stick with Python for now. How do you go about selecting libraries? Obviously, they have to be stable. Obviously, they have to do the thing you want in a relatively performant way. But what's the process of saying, hey, we'll use this versus not this? We'll build it in base Python, or we'll add a pip dependency. How do you think about that?
Yeah, I wish that we had a more rigorous way of thinking about it. We definitely made some choices in Dagster that we've come to regret in the future. An example of one of those choices is Pendulum. So I don't know if you're familiar with Pendulum, but it's this Python datetime processing library. Like the kind of analogy in my mind is in the old Java days, there was like the original Java datetime APIs, which were terrible. Then this library called JodaTime came out, which was like third-party library that everyone used instead. And so Pendulum is like kind of the JodaTime of Python. It has like much better time zone support than the standard Python libraries. Like kind of makes the right assumptions and the right defaults than compared with original Python. So we chose to depend on it until later, just discovering it was very slow. And now Python has come out and actually produced better time zone handling libraries. So we're kind of in the process of trying to undo that Pendulum decision, which has been very painful because some of our APIs actually return Pendulum objects. So there's this like whole backwards compatibility question. I think it's especially dangerous to depend on a library when you're actually surfacing types from that library instead of your own public APIs, because it makes it a much more difficult project to rip it out.
But that's super interesting. So Ben, question over to you. If you were looking to incorporate a new Python library into MLflow, what's the vetting process? And how do you ensure that something like this wouldn't happen?
There's no way to make sure it doesn't happen. I wish I had a good answer for that. My analogy for that probably resonates with you, Sandy. Typing in Python. Not, of course, there's no compile time typing validation. That's not possible in the language, but you go back to Python 3.2, the concept of applying types or type hints to things was kind of very vague. There was an external library that somebody had created that kind of supported most primitives, but the actual kernel didn't really do anything with it. And linters would, like, depending on the linter you used while you were developing, you could kind of get like, oh, there might be an issue here. You're saying this is an int, but you're actually passing in a string. We're going to like, there's some weird stuff that could happen here when you run this. You fast forward to Python 3.11, and all of a sudden there's an entire type system that's part of Python that any IDE you're using to write in, it'll just automatically detect like, hey, I'm doing an operation here with this function call that requires an integer input, and you're now passing in a potentially dangerous condition because you have an option that's coming in. It's an option int. So I don't know how to do this operation on a none. So your program could blow up at runtime. You're not going to get what you get when you're compiling Java or C or anything, which is like, you cannot do this because this is unsafe. You're just going to get a warning, but that's at least helpful. So if you use those third-party libraries and these plugins to that core language and make that as a dependency on your project, you're not just doing that for you, you're also potentially doing that for anybody who's going to be integrating with your tool. They now have to use this plugin. And then as time moves on and people are upgrading like Python, and Python's like core lang is starting to build a lot of this functionality in, there's sometimes a divergence. And then you're like, all right, what do I want to push to a user to have them have to think about? And am I going to be breaking the ability for a user to upgrade a runtime environment? Like, hey, I can't upgrade to Python 3.12 because it's incompatible with this library that you're now making me use. So that's really what we think about is not so much like, oh, is this going to be a maintenance burden? Like everything's a maintenance burden, unless it's core lang, really, in my opinion. And even sometimes core lang can be a maintenance burden. But what are you putting on? Like, what are you pushing to a user? Like, are you creating a headache potentially in the future for them? And that's what we try to avoid.
Got it. That makes a lot of sense. Okay. Because it just seems like there's the full gambit of open source tools that could do a lot of really cool stuff, but adding in those dependencies. I remember one of my earlier commits to MLflow was trying to add in like a library that did some of the functionality, and it was just like reject close, and it makes sense now. But yeah, it's just with the whole world of open source tools, you'd think that if they were stable, it'd be really cool to just be able to use them at will. So, sort of thinking out loud.
Yeah, there's the principle of minimalism, in my opinion. So if there's no compelling need to add in a new dependency and the potential compatibility issues you would have, I personally try to avoid that. Wasn't the library like Numba or something you were trying to add in?
It was something like that.
Yeah, because it was like, you were like, hey, this makes, NumPy processing so much faster. We're like, that's awesome. This is cool. But users can use that. And while they're doing their data science work, we don't need to use that, because when you look at the processing that we're doing over these array structures that are coming in, we're not doing stuff like transposing arrays or messing around with tensors. We're just taking a tensor and then serializing it or deserializing it for a user. And that we don't get the benefit of that additional library.
Numba is the one that does like JITted.
Yes. Yeah. Like
JITted
C compilation. It's blazingly fast.
Yeah, Numba's so cool.
Yeah, for any listeners who are unaware, basically it can convert simple Python code and some basic NumPy functions into compiled C just with some decorators. So if you're doing stuff like Monte Carlo simulations or just loop-based operations, it's really effective.
It's especially hard as platform software. Like if you're building a project or an application inside one company, there's a lot of things you can control that you cannot control if you're building software that everyone is going to use. So like an example of this that we've faced is with Pydantic. So I don't know if you're familiar with Pydantic. It's an amazing library. It's like data classes plus validation and, converting back and forth between JSON schemas and stuff. But there's just two versions of there's Pydantic 1, there's Pydantic 2. They have like subtly different APIs. And if we were just, building some project inside Dagster Labs, we could make a choice about we're going to use Pydantic 2. But we cannot make that choice for every one of our users. We can't say like everyone who wants to do data engineering has to use Pydantic 2. And that just means that we have this entire Pydantic, I think there's literally a large file called Pydantic compat layer inside of Dagster, Pydantic compat layer.py. That's just creates this layer on top of the different versions of Pydantic so that Dagster can work with both of them.
We had to build that last summer for MLflow, actually, because our first use of Pydantic was prior to 2.0 release for the AI gateway. because we're like, hey, we want strong typing here, and we want all the benefits of type validation when a user passes a request into the server. And Pydantic is amazing for that. It's pretty well adopted. It's solid. So we built it all out. And then they released 2.0. We're doing dev testing. So we pull like dev branches of important packages to do in CI. And we found out about that like 2 weeks before the release. And we're like, oh no, this is going to break everything. So we like scrambled real quick. We're like, we need to create different versions and then eventually abstract it away into a separate file that's very similar to that. But then you have to own that for 2 years or so before everybody finally migrates to like, hey, Pydantic 1x is end of life. It's out of support, so we're out of support for it. And they can finally delete all that code.
Yes, yeah. Now that you bring it up, CI, it's a whole other challenge, right? It's like, in addition to having the Pydantic compat layer, you need an entire like test matrix that tries all the different versions with each other.
Yeah, we have a CI suite that it doesn't even run on PRs anymore because it takes so many hours to run. So we just run it nightly on main branch, and it uses like basically every ML library that MLflow supports. It now has to do version ranging. So we test the latest micro version of every minor version of supported lists, and it takes 10 hours or something to run on. I think it's using like max GitHub Actions enterprise account VM limit. So it's something like 256 VMs that are running for 10 hours just to do all those tests every day.
Yeah.
Because otherwise, when you have to do testing on behalf of your users because you have no idea what versions they're using. You make a change on your main branch and it breaks this older version of this package. You're like, well, I just shipped a regression for my users.
And so these are packages that depend on MLflow or vice versa?
They're optional packages that users would be using to serialize and deserialize models. So like XGBoost, we're testing like 14 versions of XGBoost, the 14 most recent ones, as well as their main branch from their GitHub repo. So we'll compile and run. So
they serialize data using these libraries, but then you have to deserialize it at some point to represent it inside MLflow.
Yep.
Yeah, that's gnarly.
Yeah, I have another sort of, potentially saucy question that's very related to this. LangChain. It has been one of the fastest adopted Gen AI libraries out there and is arguably the de facto for building agents, RAG, etc. But it has a reputation of being highly unstable. So in your guys' opinion, if you were building LangChain from the beginning, do you think it's hard to make all these decisions up front and make them be good and lasting? Or, I mean, not to point fingers, or did they like make mistakes and not know how to build a library? And again, in theory, let's replace LangChain with some other project.
Yeah, I think it's such a challenging question. Like, looking at the Dagster experience, we have made, our initial APIs were around solids and pipelines, which have been entirely ripped out and removed. And then we've also made several kind of like fairly fundamental changes to our APIs since then. I think it's really hard to just say, get it right the first time. Like, I think any kind of useful platform software is in some way a research project. Like, to build something like that is new and useful, you have to be able to try a few different things. And if you could get it right the first time, it's probably because either it's like, maybe you've already built it internally inside some company, and that's great. And I think, some parts of Dagster that have been stable are kind of based on things that we've built internally in our like previous careers. But if you're actually building something new and useful, there's going to be some uncertainty that you have to manage. That said, I think there's very different people and different organizations take very different approaches to how they kind of manage that and how they deal with it for their users. I kind of always think of like the Mac approach versus the Windows approach, where like Windows, a lot of people have complained about Windows over the years, but there's like Windows binaries from like decades ago that will still run on modern operating systems. They just made that commitment to backwards compatibility, where Mac is just breaking their stuff all the time.
Yeah, think about all the different charging ports on iPhones. There's been like 17 in the past year. Like,
Exactly. It's literal like physical backwards compatibility. So, in Dagster, what we tried to do is, to some degree, you have Semver for managing this. So when we were pre 1.0, it was like anything can happen. It's scary land. You're choosing to adopt Dagster. You're sort of choosing to be on this journey with us. But then we made this kind of weighty decision to move Dagster to 1.0. And, that's just this commitment to like, okay, if we change stuff around, we still got to support the old stuff. And, maybe sucks for us, adds a bunch of extra difficulty to our lives, but there's this huge advantage that comes out of it, that people can actually build on top of the software and know that they're going to be able to, keep running their code in future versions. There's always the question of like, when's 2.0? Should there be a 2.0? I think ideally there should not be a 2.0. And the hope is that our current APIs can stand the test of time.
Interesting.
Yeah, it's a really nice take.
Yeah.
I couldn't agree more with everything you said. And particularly the one point that you mentioned about alluding to when you're first at something, you have no idea where you're going. Particularly if it's not just you're the first package that is trying to tackle this thing, but the underlying ecosystem that you're building against is actually evolving as you're building this package. That's when you're going to break stuff all the time. But there's ways to manage that like a very seasoned software engineering team that has a lot of experience in, managing software, either in private repos or in public in an open source repo, they're going to just handle it differently. Like, oh, we can't actually make this change right now without alerting users months in advance, or we need to think about preserving backwards compatibility so we don't break workflows. That stifles velocity, particularly for like a small team. Like when you're trying to build backwards compat in an open source library, you build your new implementation, you maintain the same interface, but your back end now bifurcates or is now potentially going to 4 different paths that you have to maintain throughout the entire time. So the code becomes way more complex and maintenance becomes an incredible headache when you're doing that. So I get why LangChain does what it does. We're like, hey, although they are changing in recent times, you can see like, hey, they're marking APIs as beta. Like, hey, this is a breaking change. Adopt it if you want. We're going to version this now. So we're on version 2. We could go to version 7 before we make this GA effectively, and it becomes the de facto API. And they're marking those in preparation for 1.0. But if you go back a year ago with their library, they were doing exactly what Sandy just said, which is like, hey, this is a research project. People are using it. It's awesome. Everybody's excited, but we're just trying to figure this out. And yeah, you break stuff a lot when you're in that mode.
Yeah, and it can be challenging to balance I'm making this piece of software that's a research project goal with the goals of trying to run a company, where like ultimately you're trying to get a bank to use your software. You don't necessarily want to be pitching it as a research project. So I think that's where a lot of software kind of ends up getting in a little twisted up, because you have these different pressures that are coming to present the software in different ways. In a certain way, we've been kind of lucky to have like kind of like smooth and consistent rather than like discontinuous growth trajectory with Dagster, where it wasn't like, okay, we release it and now everyone is using it. Like I assume from the perspective of the LangChain folks that there's a couple of months of just insane ramp up.
Yeah.
Which, is exciting and awesome, and, great for the project in a bunch of ways. But I think it incurs these kind of like growing pains that you don't necessarily hit if you have a little bit more chance to like iterate with a core group of users at the beginning, and make sure that what you're doing is really good. I think the strategy that you talked about of like calling some APIs beta has worked really well for us. So when we have our sort of like bed of stable APIs, whenever we add a new feature, like recently we added asset checks, which is the ability to define data quality checks for the assets that you define in Dagster. We mark those as experimental. So we give ourselves the license to iterate on those for some period of time before kind of adding them to the larger corpus of stable APIs.
Yeah, we do the same thing in MLflow. We don't have rules around when we remove it out of experimental. It's more like, okay, when was the last time we touched this? And how many people are using this? Have we gotten positive feedback about it? But if it's like, hey, we release a feature, we ask a bunch of people, like, what do you think about this? And they're like, what is that? We've never used that. And sometimes that's more like, okay, we have a docs problem. Nobody can even find this use case. Let's create a tutorial. If they get excited, and sometimes it's just kind of crickets. They're like, yeah, we know about that API. Nah, it's not for us. And if everybody's saying that, we're like, all right, this is staying in experimental, marked as deprecation in the future, and we'll just delete it.
Yeah, I mean, one of the things that I actually enjoyed the most is ripping out features in code. If it's like, this isn't being used, we can get rid of this. Often it is but by removing one thing, you create the ability to add a bunch of other stuff. The existence of this feature forced us to make these assumptions elsewhere in the product and meant we couldn't do X, Y. Now that we are deprecating this and ultimately taking it out, that means we can do X, Y.
Yeah, I haven't done it for large features, but for small ones, it's the same sensation as cleaning your apartment or like just cleaning in general, because you're like, it's so fresh, so clean. Now I can put something on there without it feeling gross. So I can definitely relate to that.
It's very Marie Kondo.
My favorite experience, though, is going through and looking at something and then basically saying to myself, like, who the hell built this piece of junk? Like, what is this? And anytime that I actually say that to myself, I know who wrote it. It's me. I go back to the commit history, like, yeah, this is my feature. Time to delete this piece of junk. And that's the best feeling. To just
doing like
I have removed my chaos from the
process where you like are like tracing who created a bit of code back through many commits, and you finally get to the bottom of it, and it's you. It's like.
Or why is this so flaky or buggy? Like, who thought this through? And then you're like, oh, I did 3 years ago. Yep. Delete or refactor the entire thing. And that's a great feeling.
Yeah. I think every time you go through one of those processes, it brings you a step closer to enlightenment.
Yeah.
Yeah. So we've been talking about how the speed of development can impact quality, sort of as an underlying theme. Sandy, are you familiar with the broken window theory?
Like Giuliani kind of New York City policing.
Yes.
Certainly.
Yeah. So the concept is basically, if there's a broken window in a neighborhood, there's going to slowly be more crime. I actually like equating it more to litter. Like if you see one piece of trash on the ground, people are more likely to litter. So this principle holds over to software engineering. I was wondering how you balance pushing out perfect, immaculate type hints, everything looks great code versus just getting it over the line, making it work, and then we'll fix it later.
Yeah, I think the kind of cop-out answer is you want to make your tooling and like internal dev infrastructure, make it so that it's easy to do the right thing. So I'm thinking about our journey with like typing, for example. So like Dagster has been around for a while. When Dagster was originally released, typing had not permeated the Python ecosystem, so we did not have types. And it's been this kind of like long journey to bring types in. It's originally like, oh, you could like run MyPy on your local dev box. And over that time, we've kind of released more and more infrastructure that makes typing stuff easier and easier. I think now we're at the point where it's like, I feel like I have a worse, development experience if I'm not typing stuff, because like I'm less likely to catch errors. Like even in my like very, granular, just trying to ship one quick change, like, and get it out today, I feel like I'll be faster if I'm adding types. And what gets us there, like, having all sorts of pre-commit hooks that do typing stuff, having integrations with IDEs, definitely was not there at the beginning. Okay, so that's kind of like one half of the cop-out answer. The other half of the cop-out answer is just enforcing stuff. So sometimes it's a little bit more annoying to do things the hard way. But if you have a step in CI that forces you to do things the hard way, then you just it becomes natural. Like your change is not going to get in if you don't lint it and run code coverage on it and all that kind of stuff. And it doesn't, even though maybe it's like requiring a little extra work of you, because you get in the habit of doing those steps, it like feels easy.
What's the line between being an annoying nitpicker and actually having real qualms with the code and bringing it up in a valid way?
Yeah, that's a great question. Trying to think of, through my own experience, like as a tech lead, a lot of my job is reviewing other people's code. And there's always this question of like, how much do you nitpick? I think the things that I personally tend to nitpick the most on are names, which probably anyone who works with me would attest to. I think like ultimately the clarity of a code base or like any piece of code comes down to like, can I look at this name and understand what it is? If you can name things that like there's a lot that you can kind of get away with if you give things good names. Because they're kind of like these anchor points. So I don't know if there's any like sort of rigorously correct answer or full answer to your question, but you kind of choose the things that your experience have taught you are really important about writing good code and latch onto those, and then try to be permissive about some of the other ones. Sometimes I'll be like, if I were to write this code, I would write it like this. You make the decision of whether you care about that or not.
Yeah, I find that sometimes, like for somebody who's new to committing to an open source project, that response works really well when I've done it, where it's like, okay, I know where this person is in their career journey, and they could probably use just seeing an example of like, hey, maybe it's the same exact logic, just written a way that validates my one big nit that I have with any code that I look at. And I have a 10-second rule on functions and methods. And that is, without context, just looking at this function implementation, like I'll zoom in a screen too. So that's the only thing on screen, like in GitHub. And if it takes me more than 10 seconds to grok what the heck is going on, the function's too complicated. There's too much stuff going on in there. Or the names are bad, which is another one. Like if you can't read it kind of like you would read English and be able to understand like, okay, there's this function call here that's somewhat complex. There's 7 arguments in here. It's going to take a couple of minutes to like figure out what the heck is going on and why these arguments are passed. But if the name of what it's calling explains exactly the action that's being taken, it's like, yeah, got it. Okay, next line. Makes sense. But if it's like, okay, there's this nested for loop in here that has all these, conditionals within it at different levels, and then it's referring to, the outer loop reference for each iteration. It's like, this sucks. Like, create a new function for this and simplify this. It should be like a one-liner for this larger control flow. That's the stuff that I tend to nitpick on, is like readability.
Yeah. I mean, like, I would totally agree, first of all. I think it's interesting for me to think about this like trade-off of like, okay, would I take a poorly named function with no unit test, but like a really clear implementation, or a well-named function with good unit tests, like a totally gnarly implementation. I think I would take the latter all the time. Like I'm willing to put up with like a gnarly implementation if it's extremely clear what it's supposed to be doing and what it's and that's actually enforced and verified. Because you can always come back and refactor that in the future to make it more clear. But if it's like not actually clear what the expected behavior is, that's going to bleed out into other parts of your code base and not just confuse someone who's looking at that function, but confuse someone who's looking anywhere that function is invoked.
Yeah, I've seen commits of people that are like, well, it's a private method. It's fine if I name it underscore A123. And it's like, what does underscore A123 do? And you look at it and you're like, all the variables are just named of letters of the alphabet, or there's anonymous returns everywhere.
It's like that's the kind of code that's like it's like obfuscated code. Like they ran a little Tumblr.
Just like, hey, we're not writing Fortran like algorithms here. Like we don't need to run this on a mainframe. Like we can use long variable names. It's fine. Verb noun, please, for methods and functions.
Yeah, my favorite one is I was supervising an intern and he wrote the names of CTEs that were about to be joined as Shaq and Kobe. And I was like, I appreciate the reference. I appreciate the irony of joining those two CTEs, but let's rename it. But yeah, that was naming is so important because you can just quickly glance at something, skim through it. Also with the table of contents type of functionality in GitHub or even some IDEs, it's really easy to see what's in your code, what's potentially missing. So yeah, names are the best. And also I think there's one more point that there's sort of selection bias in what we're looking for when we're reviewing. When we review something, we assume that it does what it's supposed to do. If it doesn't, obviously that's a massive issue. So the things that we're talking about are sort of superfluous and more for longevity of the code base instead of ensuring the thing does what it does. So Sandy, I had a question for you. Did you start as a software engineering pro? And if not, how was the transition from data science into software?
Yeah, I mean, so first of all, I definitely did not start as a pro at anything. However, my first job actually was a software engineering job. So I joined Cloudera as a software engineer and was initially working on MapReduce and then Spark, kind of these fat JVM projects for processing lots of data. But in transition from there within Cloudera to doing data science. So basically I was like, okay, it's cool that you can process tons and tons of data, but like, what are people actually using that for? And also machine learning is cool. I want to do machine learning. And this was like 2014 or something like that. Very sexy time for data science. So my transition was kind of the reverse direction of like taking my software skills and trying to use them in this more Wild West setting. It was kind of interesting coming back. So I was a data scientist for a while. I actually spent a year as a product manager writing zero code. And it was interesting after that, kind of like, can I still write code? Is it like riding a bicycle, or is it, I don't know, it's not like riding a bicycle, but did I just kind of like lose my ability to think in this way? And so it was interesting and very fun kind of coming back to these pure software roles much later, and finding that it was still something I enjoyed.
Yeah, what got stale, out of curiosity?
What got stale coming back to it? Yeah, I was honestly surprised at how quick it came back. I don't know if I can point to anything in particular that was a really tough adjustment. I guess, the horrible dependency management is one of those things that you don't really deal with when you're writing a machine learning model that you do when you're writing platform software. I guess the other thing is designing software for really diverse sets of use cases. This is maybe less about the data science to software engineering transition and more about the writing application software versus platform software transition. But you're writing application software, you're thinking about what works for me in the context of this particular domain. What are there's all these assumptions you can make about who's going to use your software because it's just the people inside your company. Whereas if you're writing open source platform software, you kind of have to believe that anyone anywhere in the world with any sort of crazy environment could be using your software, and you have to kind of make fewer assumptions and impose fewer constraints.
Got it. Flip side of that, did the hiatus help in any way? Did it give you a fresh perspective or allow you to write better code when you returned?
I definitely think that definitely yes. A couple of things there. I think through data science, you have to really learn how to interact with the domain. So I would be, trying to answer questions and build machine learning models. I worked at a health insurance company and a trucking company. And it's all about I need to understand how truckers think, or I need to understand all the complex coding of how medical diagnoses are coded. So it gives you this sort of as a software engineer, it can sometimes feel this is the user stuff that I kind of have to understand before I get back to writing code. But with data science, that so much of it is actually building this understanding that it kind of gives you this almost infinite tolerance for engaging with the world outside of the internals of what you're building. And I think that is really useful when building and designing software. From being a product manager, I think it really helps me kind of refine this more outside in kind of thinking. Nowadays, the kind of software engineer that I am is I'll write the function signature before starting on the implementation. I'll write the tests before writing the function. And I think that came out of as a product manager, you're always thinking not about the thing that you're implementing, but thinking about how it's going to be used, essentially what the interface is. And I think you can actually take that way of thinking and actually apply it more directly to the software engineering process.
Yeah, I couldn't agree more. Everybody that I've worked with, because I used to be a data science. I'm the inverse of you actually, with the start as data science, learn how to code as I went, and people that I work with now who have that prior experience of solving problems in that application programming state, and people that have done product management work in the past, it's amazing how differently they approach not just implementation, because I don't really you see the first few commits from what they're doing when they file a PR, but we do pretty extensive design docs at Databricks, and you can see the difference in how they present the problem and what they focus on. We have standard templates for designs, but a person who has always just been an IC software engineer is focusing more on design decisions that are related to functionality internal to the code, like performance, or what is the API compatibility layer between these systems, and how do we want to focus on what that handshake signature is between these. Whereas the product people, the section of the doc that talks about what does the API need to look like, what is an example use case, and they'll do up a prototype with some super gnarly code. And I do this frequently. Sometimes I don't share that code because I'm just making this work just so I have an API interface that I'm proposing, and then showing an actual example of using that API and seeing the output of it, just so that I can get other people to look at that and be like, yeah, this makes sense, or no, this sucks. Here's a different way that we should do this. And you're like, all right. But the docs actually are different in their composition based on that history. And
Totally.
I've noticed over time that the people who do the product focused one, those APIs get out of experimental faster.
Interesting.
Because they don't need modification, because so much thought and energy was put into what's the user journey here.
Yeah, a tool that I have found very useful for designing APIs within Dagster is actually to start writing the docs before implementing the API. The challenge with like adding some new concept is like, our users like, can you explain to someone who does not have this as part of their mental machinery? And by the time that I'm trying to add something, I've normally thought about something so much that it's like very deeply in there, which I think can be good, but can also lead to very unintuitive APIs because you're relying on all these like cognitive assumptions that aren't going to be there for someone who's approaching them from the beginning. So forcing myself before I actually like go in and do the implementation to actually like write out how I would explain how this works to a user often leads me to like kind of radically shift my approach.
If it's okay, I'm going to steal that technique.
Yeah.
That's a fantastic idea. I've never thought of that. Write the docs first. Like we kind of do a hybrid thing like that, where it's like explained to an executive, like in the TLDR, but that's not the same as how do I teach a user my idea? And if I can't do that in a succinct way, then that's kind of a self-writing mechanism to be like, okay, maybe this is more complicated than I thought.
Yeah, and I'm always surprised by how often my previous ideas, how often I kind of sort of prove myself wrong through this process.
Yeah, I think that's a massive time-saving exercise. I'm actually going to use that. That's a great idea.
Yeah, do you have any other genius tips for us, Sandy, on how to build code?
Oh, man. Yeah, first of all, not really. Second of all, there's the one piece that it kind of reminds me of is the Amazon style like press release driven development. You kind of like write the marketing before you write what you're working on. I don't think that's quite as useful for API design, but I still also find that sometimes useful for kind of making myself believe that I'm working on something useful or changing what I'm working on to be something useful.
Got it. That makes sense. Okay, cool. I have one final question for both Ben and Sandy, both of you. Why'd you write books?
Who first?
You.
Yeah, so the background for those who aren't familiar, I wrote or co-wrote Advanced Analytics with Spark, which is a book on how to use Spark to do data science and machine learning and all of that fun stuff. I actually recently got an email from O'Reilly saying that they just translated it into Polish and are going to send me a copy of that, which is kind of cool. Let's see. I think, maybe a couple things. I enjoy writing. I think I enjoy trying to express ideas clearly. It was something that I had not done before. So it just felt like a kind of new, exciting thing. I think it was like a useful career thing at the time, just to kind of get my name out there. Not a particularly great financial decision in terms of like the amount of work that you put in versus the compensation that you get out of it. But I still think it was totally worth it. I found it really fun.
Yeah, for me, it was sort of a response to the patterns that I noticed. And my book is very different from yours with respect to the target audience and what I wrote it for. It was because I was doing what Michael currently does at Databricks in the field, which was work with customers who are trying to get ML in production. And I just noticed patterns of, all right, I'm getting the same exact, maybe not same articulated questions over and over, but it's more of I'm noticing the same patterns at different places that have nothing to do or very little to do with implementation details. A lot of it, which is why the whole first half of my book is like, answer the why you're doing this first and then go talk to people. Don't build this thing because you get this one line item, quarterly goal from executive management saying data science team is going to be solving this problem for us. And then they just build an implementation that nobody ever uses. It never makes it to production, because even if the code is perfect and the implementation works great, nobody cares. Or it didn't solve the problem that the business actually wants. And I saw that pattern and actually lived that myself at several companies of, what happens if I don't talk to the marketing department or the sales department before writing my first line of code? You're going to build something that technically works, but nobody's going to use. And that's the worst feeling. You're like, I just wasted 6 months and everybody's pissed at me. Now I got to redo this. So
I have seen, in the world of data science, truly a tale as old as time.
Yeah. And that was the big response that I got from the book, was that mission that I was on. There's a lot of technical stuff in it and examples that some people have reached out and they're like, oh, it's so cool that you did this thing on like all these different ways of doing time series. And then I hear from 10 other people that are like, yeah, I know why you did the technical explanations to cover certain topics, but the overarching theme, particularly the first half of the book, like that's what this book's about. Like, yeah, you got it. Like, it's more communication and talking to humans, not about, well, I need to decide between these 37 algorithms, which one's most efficient and which has the highest, accuracy. It's like, nobody cares. Like, build something that works, that you can maintain. And yeah, I couldn't agree more with the compensation of the hundreds and hundreds of hours that you put into developing a book, particularly really big technical books. Yeah, my right before final review is when they did, like, Manning will do the cuts, where they're like, hey, we're targeting a book of this length and your book is either too short or too long. So either add content or remove stuff. When they did mine, they're like, yours is 60% too long. We just did the typesetting estimation and it's 1,287 pages.
Wow.
So remove more than half of this.
Damn.
And I was like, but remove what? And they're like, you figure it out. We don't do feedback to authors. You're the author. You figure it out.
Wow.
So
It's
just going through and being like,
cutting off
great,
your own leg.
these 12 chapters gone.
Yeah, definitely a don't quit your day job kind of endeavor.
Yeah.
Got it. And was it good career moves? Sandy, you said at the time it was, but I'm curious for both of you. Are you happy you wrote a book? Would you have done it again if you were in that same place?
I think it was a great career move for me. I don't regret it.
Yeah, same here. It was rough. I mean, it's working 2 full-time jobs for like a year and a half, but yeah, I would do it again. Would I do a second right now? No.
Sandy? No?
Not right now.
Heard.
Maybe a novel.
There's an idea.
Yeah, there is an idea. Okay, awesome. Well, this was a very fun conversation. We're about at time, so I'll wrap. Some things that stood out to me was, first, it's hard to make the correct decisions when you're first building a project. When you're in the pre 1.0 phase, it can be the Wild West, and 1.0 refers to your production release, where you're going to support backwards compatibility. Post 1.0, now you have to maintain and ensure that stuff doesn't break when you make changes. When you're looking to build stable code bases, when you're reviewing a PR, obviously you want the thing to work. But on the style side, just use pre-commit hooks, linters, IDEs. Make the tool annoy the person instead of the reviewer. And then if you're going to do one thing in the review, make sure that naming is good. A cool strategy for ensuring you're building the right features well, start writing the docs and or the marketing pieces before you write the code. And then finally, if you want to get rich, don't write books. So Sandy, if people want to learn more about you, your work, or Dagster, where should they go?
Yeah, I'm on Twitter as S_RYZ. That's Riz. Dagster, check out dagster.io. I'm also on GitHub as github.com/SRYZA, SRYZA.
Amazing. And check out Spark-Time series on GitHub. Scintillating.
Please don't.
Cool. Well, until next time, it's been Michael Burke and my co-host.
Ben Wilson.
And have a good day, everyone.
We'll
Thanks
catch
so
you
much
next
for
time.
having me on.
Yeah. Thank you.